Hello everyone, my name is Ming. My meeting number is 21167. Today our group is going to present about the application of integration in probability. First, I want to talk about the historic development of probability. Probability means the possibility is a less of mathematics that deals with the occurrence of the random event. Probability has two aspects. First is the likelihood of hypothesis given the event for them. Second is the behavior of the stochastic process such as the rolling of dice or coins. The study of the former is the historically ordered in such as the law of evidence. The mathematical treatment of the drive began with the work of Cardano, Pascal, and Fermat between 16th and 17th century. Next, I want to talk about the people involved in the development of probability. First is the Jerome Cardano, second is the Pierre de Fermat, third is the Blaise Pascal, fourth is the Ibrahim de Mabra, fifth is the Pierre Simon Leslie, the last one is the Carl of Legal. Now I want to talk about the application of integration in probability. The probability integral transformation involves the result that the data value model has a random value from any given continuous distribution can be transformed into random variable with the standard uniform distribution. Integral is the calculating probability for discrete cases typically involve comparing the number of the way a chosen event can occur, the number of the way or possible event can occur. Besides that, I want to talk about the importance of probability toward the understanding of our world. First, the weather forecast change of the rain for the particular period and place that is reported. Second, the forecast correlation result. Use the technique of probability to predict the outcome of the voting after the election. Lastly, I want to talk about the benefit of probability toward the understanding of our world. First, improve upon the previous interpretation. Second, provide the information about the likelihood that something will happen. Third, make the decision in context of uncertainty.
Hi, my name is Lao Jingyuan and I will explain about the key concept for the application of calculus to probability. Our project demonstrates the following concept in integral calculus. Number first, definite integrals, and second, improper integrals. The probability Px bigger and equal to A and smaller and equal to B is a measure of the likelihood that an outcome of an experiment will lie between A and B. This probability is given by a definite integral which is equal to integrate fx from b to a, and the function fx that determines the above probability for each a and b is called the probability density function of x, or of the experiment whose outcome is x. It is very important to understand that the area under the curve of a probability density function equal to 1 and it must be 1. This condition is what relates a density function to the outcome x of a specific experiment. And then we come to improper integrals. This section extends the concept of the definite integrals to integrals of the form, which is integrate fx from positive infinity to a, in which the upper limit of integration is not a finite number. Such integrals are known as improper integrals fx and arise in a variety of practical situations. For example, if f is non-negative, the improper integral fx can be interpreted as the area of the region after the graph of f to the right of x. Although this region was infinite extent, its area may be either finite or infinite, depending on how quickly fx approaches 0 as x increases.
Good afternoon, sir. My name is Yong with matrix number 279598. Now, I'm going to explain the methods that is used to achieve the objective of this project. The probability density function has the properties that fx greater and equal to 0 for all values of x in a closed interval a and b, while integrate fx from a to b shows that the area under the curve y equal to fx between x equal to a and x equal to b is equal to 1. A definite integral can be evaluated using the fundamental theorem of calculus part 2 as follows. If the function is continuous on closed interval a and b, and f is any antiderivative of f, then definite integral of f from a to b is given by the formula as shown below. For example 2, we find the probability of the exponential function by using integration by substitutions. By using U substitutions, we can easily integrate the function. An improper integral is a definite integral that has either of both limit infinite or an integrand that approaches infinity at one or more points in the range of integrations. Through integrations, we can determine whether an improper integral is convergent or divergent. For example, let f(x) be continuous over an interval of the form closed interval a and positive infinity open interval. Then, a formula as shown below, provided this limit exists. If the limit is finite, we say that the integral converges, means can do the integral. Well, if the limit is infinite or doesn't exist, we say that the integral diverges, means can't do the integral. Integration is one of the most recently applied calculus methods in determining the probability of function which lies between an interval. That's all from me. Thank you.
For example 1, here is a plot that Gervais claims is of a probability density function. A. We need to verify that this plot shows the requirement of a probability density function. B. We need to calculate the probabilities of x equal and smaller than 4. X equal and bigger than 4 at the meantime is smaller and equal than 6. And the third one is x bigger than 7. Furthermore, we also need to calculate the value of r such that integrate r to infinity fx is 0.5, where r is called the median of the distribution. For the solution for part A, this is the probability density function. This is because that the function is never negative and the area under the curve sums to 1. For part B, the probabilities can be determined by calculating the areas from the graph. Hence, for the probability x equal and smaller than 4, the answer calculated from the graph is 1/2. The probability of x equal and bigger than 4 at the meantime is smaller than 6. The answer calculated from the graph is also 1/2. For the third probability, which is x bigger than 7, the answer calculated from the graph is equal to 3/20. So for the fourth answer, since this is a symmetric distribution, hence the median is at its physical center. Therefore, r is equal to 4.
Good day, doctor. My name is Shao Ming. Then I'm continue to present about the example and analysis. For example 2, we link to the key concept using definite integral to calculate the probability for the wait time for a cable TV customer service operator to answer the call. So example 2, the function representative the wait time for a cable TV customer service operator to answer your call has a mean mu of 6 minutes. So A, create a probability density function for this situation. And B, calculate the following probabilities using your probability density functions. Okay, so first for all, for question A, we know that exponential distribution is suitable to use in this situation. So possible probability density function is Px equal 1/6 e power neg x/6 for x bigger or equal to 0. And you can verify that this is a probability density function by showing that integrate Px from 0 to infinity is equal to 1, and that the mean wait time is mu equal Ex equal integrate x times Px from 0 to infinity is equal to 6. So for question B, calculate the following probabilities using your probability density function. So B1, P bracket x is smaller or equal to 4 is equal to integrate Px from 0 to 4. Then if after you integrate by using the substitution, then you will find the answer is 0.4866. Okay, for B2, P bracket 3 is smaller or equal to x and x is smaller or equal to 7. So you can write that equal to integrate px from 3 to 7 and use the same method for the B1 is integration by substitution, then we will find the answer is 0.2951. And for B3, p bracket x is bigger than 10 is equal to integrate px from 10 to infinity, and after the integration, you will find the answer is 0.1889. For B4, p bracket x is bigger to t is smaller or equal to 1 or 100. So you integrate the px from t to infinity is smaller or equal to 0.01. Then after your integration, you will find that e power negative t over 6 is smaller or equal to 0.01. Then you both sides substitute the ln. Then after you substitute the ln, you will find the answer t is equal to 27.631 minutes.
In conclusion, we can determine that integration is commonly used in statistical analysis, especially when a random variable takes a continuous value. Here, we will learn what probability distribution function is and how it functions with regard to integration. For the first example, area under the PDF for all possible values of the random is equal to 1. For the second example, we determine the probability for the wait time for a cable TV customer service operator to answer the call by using the infinite integral, which is the mean time is 6 minutes. In probability theory, a probability density function, which is PDF or density of a continuous random variable, is a function that describes the relative likelihood for this random variable to take on a given value. The probability for the random variable to fall within a particular region is given by the integral of this variable's probability density over the region. The probability density function is non-negative everywhere, and its integral over the entire space is equal to 1. And that is all from us. Thank you.